Okay, hello everyone. In this lecture, we will see two questions of your steady state level flight of your aircraft performance, right? Aircraft performance, and this question I have picked from your NPTEL. And this kind of question, the formula-based question, they have asked in your GATE exam many times for 1 marks. Generally, they ask for 1 marks for the formula base, and this question is from your steady state level flight. Okay, so let's read the question. The question is saying if the weight of the aircraft is 765 kg and lift to drag ratio of the aircraft is 11, what is the thrust required in Newton at a cruise condition is? So let me tell you first what is the cruise condition. Okay, so okay, let me draw the aircraft first. Pardon me for my diagram. Okay, now see what is cruise condition. Cruise condition means, let's say this is your aerodynamic points, aerodynamic center, and okay, cruise condition means what happens, your thrust, and this is your drag, and this component is lift, and this component is weight. Okay, so weight is nothing but m into g, right? Now the steady state level flight, or your cruise condition, you can say cruise condition means your thrust will be equals to drag, okay, and weight will be equals to lift. That means you are not accelerating. That means, and that's why this cruise condition deals under the unaccelerated flight unaccelerated flight part. And we have one more part, that is accelerated part. In that we see the pull-up maneuver and pull-down maneuver. In that velocity during the flight continuously changes. Okay, in this velocity will not change. Okay, so if you see, this is the condition of your cruise, in that thrust is equals to drag and weight is equals to lift. Okay, so using this condition you will maintain the cruise condition. Okay, okay, let's see. Now they have asked the thrust required, right? Thrust required, if you see, basically thrust required for the cruise condition is nothing but drag. So we know that for the cruise condition also thrust required is equals to drag, right? So now we need to find out drag, or otherwise you find thrust, right? And we can equate it at the end, right? So okay, let's try to find out. I know the drag is given by weight into drag divided by lift. For the cruise condition we have a minimum drag condition, but they have not given anything. They have just given the lift to drag ratio, so we are just using the lift to drag ratio. Okay, so in the coming of the lecture we will see what is the minimum drag condition, what is the minimum power condition, what is d by v condition. So we will see all this condition. Okay, so as of now they have not mentioned anything, so I'm not touching all those. Okay, let me change the color. Okay, fine. Now if you see in this, to find out drag we know weight is nothing but mass into gravity, right? Now if you see, we have a mass, because if you see this is 765 kg, that means they have given mass. Gravity is not multiplied. If you multiply the gravity, it comes into the Newton. So I'm multiplying the gravity in this case, which is 9.81 I'm taking. As of now they have not given the gravity, so I'm taking it as 9.81, which is universal. And if you see, they have given lift to drag ratio is 11. Okay, so if I convert into the drag to lift, it becomes the inverse, right? So let me divide it by 11. So if you divide this by 11, you will get this as a I'm getting this as a 682.24 Newton. Okay, so drag is drag for the this condition for lift to drag is 11. When lift to drag ratio is maintained as 11, you will get drag as a 682.2 Newton, and which will be also is equals to thrust, right? So I hope you know how what is the cruise condition, what are the condition we have: thrust equals to drag, lift equals to weight, and accordingly your drag will be equals to thrust. So the I think the numerical is over. No catch involved is numerical, right? So option A is a correct option. And this kind of question you can expect for 1 mark, and you can easily get 1 marks if you know the concept, right? Okay, I hope this question is clear. Now let's go for the second question. Okay, yes. Now if you see this question, this is just a modification of that question. Now they are asking the same question: what is the power required in kilowatt at cruise condition? Right now, again, we know that in a cruise condition, in a steady state level condition, thrust equals to drag, and lift lift force. So what are these? These are the nothing but aerodynamic forces, which are acting on the aerodynamic center, right? So okay, let me write clearly. Thrust is equals to drag, and lift is equals to weight of aircraft, and all these are in Newton. Okay, these are in Newton. So these are the nothing but what is this? What is these are the aerodynamic forces. Okay, please keep this thing in mind. Okay, now they are asking the power required, right? Power required is nothing but velocity into drag, or for the steady state level condition or cruise condition, we know that drag is equals to thrust. So we can write in this way or we can write in this way, both are correct. So if you see, power required is nothing but velocity. I'm taking it as drag for as of now. Now we have same question, and we have calculated the drag value, right? We have calculated drag also. Drag was 682.24 Newton, and the velocity of the aircraft, this is the nothing but the velocity of aircraft. So well, they have given that the aircraft flying at a speed of 50 meter per second. If you see, they have gained 50 meter per second. So we know that this is 50 velocity of aircraft, and drag is nothing but 682.24, which is nothing but equals to thrust also. So if you multiply both these two, you will get power required for that to fly at a to maintain a cruise condition. So this becomes your power required, and it will, if you calculate this, it will come out to be 31.11 kilowatt. So if you multiply this both, you will get in watt, nothing in watt. So to convert into the kilowatt, what you have to do, you have to divide by 1000. So when you divide it by 1000, you will end up into the kilowatt. So option 4 or option D is correct for this. And I hope this concept is clear. What is the cruise condition, and what are the key point in that, right? What is thrust equals to drag, and all these things, and how to calculate power required, or power, or velocity, all these things. So keep this thing in mind. Many times they give the mass of the aircraft, they will not give the weight of the aircraft, so you have to multiply with the gravity. So as of now they have not given anything, so I'm taking it as a 9.81. But when at the altitude, at the, let's say, 5 kilometer altitude, or let's say 10 kilometer altitude, they will provide the gravity, because as altitude increases your gravity changes, right? So ideally they should provide the gravity, so you need to multiply with that gravity. Okay, so I hope this is clear. If not, you can ask me in a comment section. I will try to answer there. Okay, let's meet in our next lecture. Thank you.